The real difference between equipment fed with 208 volts single-phase versus 208 volts three-phase extends beyond just a lower overall amperage. Let's delve into the theoretical considerations and practical applications that highlight these differences. Firstly, power factor. Three-phase systems generally have a higher power factor, typically 0.9 or better, compared to single-phase systems, which are typically 0.8 or less. This higher power factor means that three-phase systems can transfer more real power for the same amount of apparent power. In simpler terms, they are more efficient in utilizing the supplied power. Secondly, motor efficiency. Three-phase motors are generally more efficient than single-phase motors, particularly at higher loads. This is because three-phase motors have a more balanced magnetic field, which reduces torque pulsations and energy losses. The smoother operation contributes to less wasted energy and improved overall performance. Thirdly, voltage balance. Three-phase systems have inherent voltage balance, meaning the phase-to-phase voltages are equal. This balance is crucial for sensitive equipment that is susceptible to voltage imbalances. Uneven voltages can cause equipment malfunction or damage, making three-phase systems more reliable in such scenarios. Fourthly, fault tolerance. Single-phase systems are more susceptible to faults than three-phase systems. If one phase of a single-phase system fails, the equipment may cease to operate or may even be damaged. Conversely, a three-phase system can often continue to operate, albeit at a reduced capacity, even if one phase fails. This redundancy provides a high degree of reliability, especially in critical applications. Moving on to practical applications, let's consider electric motors. Three-phase motors are typically used for large high-power applications like industrial machinery, pumps, and blowers. Their efficiency and power capabilities make them well suited for demanding tasks. Single-phase motors, on the other hand, are typically used for smaller, lower-power applications such as fans, air conditioners, and refrigerators. Their simpler design and lower cost make them ideal for residential and light commercial uses. Now let's talk about power distribution. Three-phase power is commonly used in industrial and commercial settings where high power demands are prevalent. Factories, large office buildings, and shopping malls typically rely on three-phase power to operate their equipment and systems. Single-phase power is typically used in residential and small commercial settings where power demands are lower. Homes, small shops, and individual offices often utilize single-phase power. Next, uninterruptible power supplies, or UPS systems. Three-phase UPS systems are typically used for critical loads such as data centers and hospitals, where a continuous power supply is essential. These systems provide backup power to ensure that operations are not disrupted during power outages. Single-phase UPS systems are typically used for smaller, less critical loads such as personal computers and home appliances. They offer protection against power surges and brief power interruptions. Then lighting. Fluorescent and high-intensity discharge or HID lighting fixtures typically require three-phase power, particularly in large commercial and industrial spaces. These types of lighting often require the higher voltage and power capabilities of a three-phase system. Incandescent and light-emitting diode or LED lighting fixtures can operate on either single-phase or three-phase power, making them versatile for various applications. Finally, arc furnaces. Arc furnaces used in metalworking typically require three-phase power to generate the intense heat and magnetic field necessary for melting and refining metals. The balanced power delivery of a three-phase system is crucial for the efficient operation of these furnaces. In summary, three-phase power systems offer notable advantages over single-phase systems in terms of power factor, motor efficiency, voltage balance, and fault tolerance. These benefits make three-phase systems well suited for high-power applications, industrial environments, and critical loads where reliability and efficiency are paramount. When selecting between single-phase and three-phase power, it is essential to consider the specific requirements of the equipment and the application, taking into account factors such as power demands, efficiency needs, and criticality of operation. The selection of a power system should be carefully evaluated to ensure optimal performance and reliability. In a three-phase system, the power is delivered by three alternating current conductors, each carrying a voltage that is 120 electrical degrees apart. This configuration results in a more constant and consistent power delivery compared to a single-phase system, where the voltage fluctuates more significantly. The consistent power delivery of a three-phase system contributes to its superior performance in high-power applications. In contrast, a single-phase system delivers power through two conductors, a hot wire and a neutral wire. The voltage in a single-phase system alternates in a sinusoidal pattern, with the power fluctuating between 0 and a maximum value. This fluctuation can cause voltage drops and other issues in high-power applications, making single-phase systems less suitable for such uses. The high power factor of a three-phase system means that it can deliver more real power for the same amount of apparent power. Real power is the power that is actually used to perform work, while apparent power is the total power delivered by the system, including both real power and reactive power. Reactive power is the power that is stored and released by inductive and capacitive components in the system. A higher power factor indicates that a larger proportion of the apparent power is being used as real power, resulting in greater efficiency. The enhanced motor efficiency of three-phase motors is due to their more balanced magnetic field. In a three-phase motor, the three phases of current create a rotating magnetic field that is more uniform and consistent than the magnetic field in a single-phase motor. This balanced magnetic field reduces torque pulsations, which are fluctuations in the torque produced by the motor. Torque pulsations can cause vibrations, noise, and reduced efficiency. The inherent voltage balance of three-phase systems is crucial for sensitive equipment. Voltage imbalance occurs when the voltages in the three phases of a three-phase system are not equal. Voltage imbalance can cause a variety of problems, including overheating of motors, reduced efficiency, and equipment malfunction. Three-phase systems are designed to minimize voltage imbalance, making them more reliable for sensitive equipment. The improved fault tolerance of three-phase systems is due to their ability to continue operating even if one phase fails. In a single-phase system, failure of a single phase will cause the entire system to shut down. However, in a three-phase system, the remaining two phases can continue to deliver power, albeit at a reduced capacity. This redundancy can be critical in applications where a continuous power supply is essential. When it comes to electrical motors, three-phase motors are the workhorses of industry. They are used in a wide variety of applications, from powering large machinery to driving pumps and fans. Their high efficiency, reliability, and power capabilities make them the ideal choice for demanding applications. Single-phase motors are typically used in smaller, lower power applications where efficiency and power are not as critical. They are commonly found in appliances, tools, and other household items. In power distribution, three-phase power is the standard for industrial and commercial settings. It is used to power everything from lighting and HVAC systems to large machinery and data centers. Single-phase power is typically used in residential settings where power demands are lower. Uninterruptible power supplies are essential for protecting critical equipment from power outages. Three-phase UPS systems are used in data centers, hospitals, and other facilities where a continuous power supply is essential. Single-phase UPS systems are used to protect smaller, less critical loads such as personal computers and home appliances. The type of lighting used in a building can also influence the choice between single-phase and three-phase power. Fluorescent and HID lighting fixtures typically require three-phase power, while incandescent and LED lighting fixtures can operate on either single-phase or three-phase power. Finally, arc furnaces, which are used in metalworking to melt and refine metals, require three-phase power to generate the intense heat and magnetic field necessary for the process. In conclusion, the choice between 208V single-phase and 208V three-phase power depends on the specific requirements of the application. Three-phase power offers advantages in terms of power factor, motor efficiency, voltage balance, and fault tolerance, making it suitable for high-power applications, industrial settings, and critical loads. Single-phase power is typically used in residential and small commercial settings where power demands are lower. By understanding the differences between these two types of power systems, you can make informed decisions about which one is best suited for your needs. When considering the application of three-phase power, one must also take into account the requirements of the National Electrical Code, or NEC. The NEC provides guidelines for the safe and proper installation of electrical systems, including three-phase systems. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on their size, insulation type, and ambient temperature. When installing a three-phase system, it is important to select conductors that are properly sized to handle the expected current load. The NEC also specifies requirements for overcurrent protection devices, such as circuit breakers and fuses. These devices are designed to protect electrical systems from overloads and short circuits. When installing a three-phase system, it is important to select overcurrent protection devices that are properly rated for the system's voltage and current. Grounding is another important aspect of electrical safety. The NEC requires that all electrical systems be properly grounded to protect against electric shock. Grounding provides a low resistance path for fault currents to flow back to the source, which helps to trip overcurrent protection devices and prevent electrical hazards. When installing a three-phase system, it is important to ensure that all equipment is properly grounded. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It is important to check with your local authorities to ensure that your installation complies with all applicable requirements. Properly trained and qualified electricians should perform all electrical work. Working with electricity can be dangerous, and it is important to have the knowledge and skills necessary to perform the work safely. By following the NEC local codes and the recommendations of qualified electricians, you can ensure that your three-phase system is installed safely and properly. When considering the application of three-phase power, it is also important to consider the cost. Three-phase systems can be more expensive to install than single-phase systems, particularly if the building is not already wired for three-phase power. The cost of three-phase equipment, such as motors and transformers, can also be higher than the cost of single-phase equipment. However, the higher efficiency and reliability of three-phase systems can often offset the higher initial cost. Over the long term, three-phase systems can save money on energy costs and reduce the risk of equipment downtime. When evaluating the cost of a three-phase system, it is important to consider all of the factors involved, including the cost of equipment, installation, and energy. It is also important to consider the potential benefits of three-phase power, such as increased efficiency, reliability, and power capacity. By carefully weighing the costs and benefits, you can make an informed decision about whether three-phase power is the right choice for your needs. The selection of the appropriate voltage level is crucial for optimizing performance and safety in electrical systems. 208 volts, 240 volts, 277 volts, and 480 volts represent common voltage levels used in various applications, each with distinct characteristics and suitability for specific loads and environments. Understanding the nuances of these voltage levels is essential for electrical engineers, technicians, and facility managers to ensure efficient power distribution and equipment operation. 208 volts is typically found in three-phase systems commonly used in commercial buildings and light industrial facilities. This voltage level is derived from a 208 Y/120 volts Y-connected transformer, where 208 volts is the phase-to-phase voltage and 120 volts is the phase-to-neutral voltage. 208 volts is well suited for powering a variety of equipment, including lighting, HVAC systems, and machinery. Its advantage lies in providing a balanced three-phase power supply that minimizes voltage imbalances and ensures efficient operation of three-phase motors and other loads. 240 volts is commonly used in residential and light commercial applications, often supplied as a single-phase system. It is derived from a split-phase transformer, providing two 120 volts legs that can be combined to deliver 240 volts. 240 volts is suitable for powering larger appliances such as electric stoves, clothes dryers, and air conditioners. While 240 volts can also be used in three-phase systems, it is less common due to the widespread availability of 208 volts in commercial settings. 277 volts is primarily used for lighting circuits in commercial and industrial buildings. It is derived from a 480Y/277 volts Y-connected transformer, where 480 volts is the phase-to-phase voltage and 277 volts is the phase-to-neutral voltage. 277 volts is favored for lighting because it allows for longer circuit runs with less voltage drop compared to lower voltage levels. This reduces the number of circuits required and lowers installation costs. 480 volts is commonly used in industrial facilities and large commercial buildings to power heavy machinery, large motors, and other high-power equipment. It is derived from a 480Y/277 volts Y-connected transformer or a delta-connected transformer. 480 volts is advantageous for high-power applications due to its ability to deliver large amounts of power with low current, reducing conductor size and minimizing voltage drop. When selecting the appropriate voltage level, factors such as load requirements, equipment compatibility, and safety considerations must be taken into account. Lower voltage levels like 120 volts and 240 volts are generally safer for residential applications, while higher voltage levels like 277 volts and 480 volts are more suitable for commercial and industrial settings where higher power demands are prevalent. Additionally, the type of grounding system employed can impact the selection of voltage levels. Solidly grounded systems are commonly used with lower voltage levels, while impedance grounded systems are often used with higher voltage levels to limit fault currents and reduce the risk of arc flash hazards. Ultimately, the selection of the appropriate voltage level requires careful evaluation of the specific application and adherence to relevant electrical codes and standards. By understanding the characteristics and suitability of different voltage levels, electrical professionals can ensure safe, efficient, and reliable power distribution systems. The choice between single-phase and three-phase power systems hinges on factors like power requirements, efficiency needs, and application-specific demands. While single-phase systems serve well in residential and light commercial settings, three-phase systems stand out as the preferred choice for high-power applications, industrial facilities, and critical loads. The distinct advantages of three-phase systems, including high power factor, improved motor efficiency, voltage balance, and fault tolerance, make them indispensable in scenarios where reliability and performance are paramount. When deciding on the type of power system to employ, careful consideration must be given to the specific requirements of the intended application, taking into account the factors mentioned above. Understanding the intricacies of both single-phase and three-phase systems allows for informed decisions that optimize performance, efficiency, and safety. Ultimately, selecting the right power system ensures seamless operation and minimizes the risk of disruptions in critical environments. By carefully weighing the pros and cons of each system, users can make choices that align with their specific needs and contribute to the overall success of their operations.